Homework 11, question 2. For this question, we need to prove that the following function can be represented as the autocorrelation function and the density power function. If we want to prove that R of tau is an autocorrelation function of a real WSS stochastic process x of t, and we need to prove that the R of tau is even and R of tau is smaller and or equal than the R of 0, and for its Fourier transform must be the non-negative. And for another one, if we want to prove that the function x of tau is the power spectral of the WSS process xt, we need to prove that the x of omega must be non-negative. The first one, f of v equal to e to the minus absolute of v. We can easily to find that e to the power minus absolute of v is even, because the minus v, f of minus v is equal to fv, and when v equal to 0, this f of v equal to 1, and otherwise f of v must less than 1, and we just take the Fourier transform to the f of v. We got 2 alpha divided by alpha square plus omega square. This part must be non-negative, so that we can know that f of v can represent an autocorrelation function. And for second part, we can easily find that f of v must be larger than 0, so that f of v can represent a power spectral function. For the part B, f of v equal to sine v squared divided by v squared, and if we cannot directly take v equal to 0, because f of v will become invalid. So we just do the limitation while tau equal to 0, and this part is equal to 1, and for any part other than tau equal to 0 must less than 1. So it has satisfied that R of tau less than R of 0. And we can take the minus tau instead of tau, plug in the function R of tau, and we can modify the function to this part, and which is equal to R of tau, and so that the function is even. And if we do the Fourier transform of tau, we know that it must be larger than 0, so it's non-negative. The f of v can represent an autocorrelation function. And for the power spectral function, we just need to know, easy to find the sine omega squared divided by omega squared must larger than 0, so the f of v can represent an power spectral function. And the third one, f of v is a conditional function. Well, v the absolute of v is smaller than alpha is equal to 1, otherwise 0. This must be even, because whatever you choose minus v or v, this part doesn't change the value of f of v. And for R tau is less than R0, and do the Fourier transform R sine omega divided by omega. This part is not non-negative, so it cannot represent an autocorrelation function. And from this part, we can easily find that S of omega is larger than 0, so it can represent a power spectral function.